So thank you very much for coming to the talk. I know some of you are suffering badly from last night. Hope it wasn't too bad, or it's not too bad today anyway. My name is José Dominguez. I worked on software for many years, and a year ago, in September 2015, I decided that I didn't want to do software anymore. I wanted to work on data. So I started a PhD. I quit my job, started a PhD at Maynooth University, which is just outside Dublin in Ireland. And I'm part of the Insight Centre for Data Analytics, which is a research centre in Ireland. If you're interested in doing any kind of research, or if you want to look at scholarships for PhDs and research masters, stuff like that, check us out. We do have stuff from time to time coming up. So I'm still quite active in software. I do quite a bit of open source stuff. So I'm a contributor in MIT App Inventor, Coder Dojo. You guys do Coder Dojo here in Poland, right? Yeah, teaching kids, computer club, that kind of thing. And I do small contracts from time to time. I'm a contractor with the Mozilla Foundation right now, working on a project with the Science Lab. So I'm also a co-organizer of CATSConf, which is a conference in functional programming languages that we run for the first time in Dublin in 2015. There is a mini CATSConf tomorrow in Belfast. You're probably too late to get there. But we are coming back on the 18th of February. We still haven't opened the call for papers. But if you are interested in functional programming, this is a good place to go. This is the agenda for today. Just to make sure that everybody's in the right room, you didn't go to the wrong talk. The talk title is very, very long, and I'm going to try and explain why the different parts of the title. So I'm going to try and explain what I mean by Homespun and what's your things and your data. I'm going to do a very, very brief introduction of what data science is, and it's going to be kind of basic. I have a lot of material. I might not be able to go through all the material, but I'll post the slides. Most of the slides have a link to resources, so if you want to... this is basically what I've been doing for the last year to try and transition. So there's a lot of links if you want to do a similar transition or just are interested in data. There's a lot of links to explore and see just explore, basically. So then I'm going to show you a few tools. I like this term. Has anyone come across the term end-user development before? I don't see any hands, but I might. Right, I'll explain what end-user development is. You've all used it, even if you don't know the term, but I'm 100% sure that you've all used end-user development tools. So Homespun is basically simple and unsophisticated, just like me. Just keep it simple. Especially if you're transitioning or if you're coming, I have a computer science background, and when I started, there were so many things. I work with wearable devices, so I didn't know if I had to start learning digital signal processing or if I had to start learning all this machine learning thing, what is machine learning? There's so many stuff, so much stuff. So if you can keep it simple, it's a lot better. When I talk about your things, I'm also talking about keeping it simple. So use something that you already have. So you might not have a smartwatch. I don't have one, but you all have mobile phones, probably more than one. You might have a tablet. This thing in here is a heart rate monitor. You strap it to your chest, and it sends information through Bluetooth to your phone, and it tells you if your heart is beating at 60 or 70 or 120 if you're running, something like that. That thing, well, a very similar one I bought in Lidl, in the supermarket, for about €19. So they're very cheap, and it's very easy to work with them, especially on Android. They're actually, the Bluetooth connection is very, very easy. So you can go all crazy. This is the first thing I did was I'm going to get Arduinos and put them all over my house and get temperature sensors and humidity sensors and all this kind of stuff. And I ended up collecting, I mean, it's very easy to get started, but it gets complicated very easily. You start collecting all this data, and you've no idea what to do with the data. If you were at Evelina's talk yesterday, she was saying exactly this. You're given 2 terabytes of data and no questions to answer. So if you don't have a question, you don't really need the data for anything. So you're going to see this slide a lot today because I want to focus on keeping it simple and just start using something. The main problem with this was also that when this is very familiar. You're all developers, or most of you are developers. You know how to figure out a little bit of C. And when you get this done, you get this kind of accomplishment feeling that you don't go any further. So you don't do the rest of the pipeline. You already have results, so you're happy. You don't do anything else. So I would try and avoid that. If I were to start again, I would definitely try and avoid that. But if you do need complicated stuff, there are plenty of platforms out there. So if you have a lot of mobile phones connecting to your network, you need to keep track of all the mobile phones. You need an operational DB and probably a time series DB. You need APIs. You need all that kind of stuff. There are platforms for that. All the stuff that I'm going to be showing here is open source. So the Ka platform is a good place to start if you want to scale, if you want to do this properly, not unsophisticated like I'm going to be talking about here. There's also ThinkSpeak. There's even a full operating system for IoT things, whatever that is, made by Google. It's called Brillo. If you want to read more about types of platforms out there, paid, free, open source, this blog post is actually quite good. It has a lot of information on platforms. But the harder part for me was actually trying to change into learning mode, because you've probably seen this before. I did a lot of JavaScript in the last 5 years, and every 6 months you need to learn something new because Backbone is, and now we all do React or something else. So the way that you deal with this is you buy a book, or you go to the internet, read a few tutorials, and you spend a few weeks and you figure it out. In the end, you're going to figure it out. So I thought, okay, this machine learning business is exactly the same thing, right? So what I'm going to do is I'm going to Coursera, and I'm going to do Andrew N's class, and that's going to sort me out. And it didn't. By the end of week 3, I had no idea what was happening. I had no idea why if you multiply this matrix with this other matrix, you get something else. My linear algebra was completely deleted from my brain. I suppose I suffered a lot when I was in college or something. So this did not work for me. It might work for you. I might be dumb, I don't know, but it might work for you. So let's try and focus again on your things, things that you probably already have. What kinds of things can you do? So for instance, there is a depiction of a phone. You can get accelerometer data, and what you get from the accelerometer is 3 axes. You get X, Y, and Z, and you can do zero-cross analysis, and it sounds kind of complicated, but it's very simple. This is a normal sinusoid, and when the signal crosses the axis, that's your zero-cross, basically. So here you have 1, 2, 3, 4, 5 zero-cross. if you plot the data from the accelerometer, depending, you saw here that depending on the position of the phone, the axes are going to be different. But let's forget about that for now. Let's say that you plot your x or your y-axis. You get a signal like this. If you do zero crossing, you get more or less an estimation. It's a rough estimation of the number of steps that you took. So this is basically a person walking with the phone in their pocket or something like that. It also depends on where the phone is and if the sensor is very low or is very. It's kind of complicated, but this is very, very simple to get started. But why are you going to do all this if you can go to the shop and buy a Fitbit for $60 or whatever it is, and they already do it for you? You don't have to worry about anything. You see all these pretty pictures and graphs and stuff. This is when your data comes into play. If you use any kind of commercial stuff, you should read the terms and conditions that comes with that. These are the terms and conditions. That's a lot of text. These are the terms and conditions from any Google API. If you're a developer and you use a Google API, let's make it a little bit easier. So Google does not acquire any ownership, so the data is yours. That's a good thing. But you get Google perpetual license to use, and use means use. Who would have thought? Host, store, modify, communicate, and publish, right? So they have access to your data. Actually, look at this. It's sublicensable. What does that mean? Does that mean that they can share it with anyone that works with them? I'm not a lawyer, but it sounds kind of like that. This is the terms and conditions from Fitbit. Again, if you make it a little bit simpler, you return all rights. You grant Fitbit license, sublicensable license to publish, perform, or distribute your content however they want. I don't know you guys, but I'm not okay with this. I don't like the sound of any of it. Some of you might be saying, but Google already knows everything I do. I have an Android phone, so why should I care? Well, this is actually from an academic paper. So every claim that I do here has a reference. So it's not just me making up stuff. But with a day's worth of geolocation data, that's your GPS coordinates, you can infer. If you're traveling to or from work, you can infer where you live, and you can infer where you work, or where you go to school if you're still in school. That's actually a bit of a problem in privacy terms. You ever seen this website? Please rob me. They basically, it's to raise awareness, right? But if you're on holidays in Italy with your whole family and you check in somewhere on Facebook and you put up a picture of your whole family and you tag it on Twitter, people will know that your house is up for grabs, basically, the things inside. So that's worrying. This is, people say, well, all the data is anonymized, so I don't really care. But when you mix an anonymized medical database and a list of voters, they were able to extract the health record of the governor of Massachusetts. This is quite serious. I mean, you don't want your neighbors to know that you're on antidepressants or something like that, right? You want to keep that kind of information to yourself. More stuff. Using publicly available data. This is data that you can get just off the internet. You can get your average income, how much you pay for your house if you're in debt, your political views. Some people are very vocal about their political views. For other people, it's kind of private. Worrying as well. There's even more privacy concerns if you talk about fitness devices, because it's all medical data, even though it's not proper medical. Another paper, they talk about this kind of apps as surveillance, identification, insecurity, disclosure, and aggregation. This is mostly for targeted advertisement. If you're not convinced yet, gonna give you another couple of reasons. Data could be used to legally or illegally restrict individuals to access markets. It can actually be used to discriminate against you on employment, healthcare and insurance, and credit-based lending. So say that you go for a job interview and it's up to just the last two of you, and you can see that one of the guys goes to work every day at 8:30, leaves at 6:30, goes to the gym, then goes home and only goes out at the weekends. The other guy gets to work about 10:30, leaves about 5, goes to the pub, spends the night in the pub until they kick him out around midnight, and then goes home, hopefully. Who's going to get the job? Second guy, obviously. No doubt. Who would have wanted to work with someone that goes to the gym? So anyway, so as you can see, it's not just advertisement, right? I mean, ads are horrible, but it's a lot more than that. So if you work in research, I work with a lot of researchers who don't necessarily have a technical background. So if you're in a university, you basically need to do an ethics proposal, and the ethics committee approves what you do. And in the ethics proposal, you say that only yourself, your supervisor, and your friend Joe, the senior developer in there, who is going to make an app for you, those are the only 3 people that are going to have access to the data. Now Joe goes off and uses a Google API, and now you're in trouble because a lot more people than you thought have actual access to your data. A little bit more reading. This is recent, I think, September 6th. If you want to know, or you probably read things like this before, but why do we get so many freebies? They might not be as free as we want them. So this, in my research, I'm trying to go towards a decentralized type of network. If you think about blockchain or Bitcoin, something based on that. So you don't want Fitbit here in the middle, or Facebook, or Google, or anyone. You want to have a little bit more control of what happens. I'm not going to go into detail about this, but not everybody thinks decentralization is a good thing. So if you want to read a bit more, the revolution will not be decentralized. That's a link in there. If you're interested, though, have a look at projects like this. Blockchain, you've all heard of Bitcoin, Ethereum. Ethereum is another blockchain and another implementation, and they actually have I think it's Philips. They are building a health network on top of Ethereum, and this is a new project at MIT, which is a bit more about semantic web, but it's also about decentralization, privacy, especially privacy and security. So anyway, we want stuff, and I don't want to use Fitbit or Google Fit or anything like that. You might still want to use it. So tiny bit of data science. How many of you are familiar with this diagram? 1, 2, 3, 4, 5. Cool. All right. So this is a depiction of data science, right? On one side, on one side you have hacking skills. On the other side you have statistics, and you also have to know what you're doing, right? Be a bit of an expert on the stuff that you're doing. If you look at the intersection between statistics and expertise, you get traditional research. This is what people do in R&D departments and universities and stuff like that. If you look at the intersection between hacking and stats, you get machine learning. Some people call it statistical learning. Some people call it data mining. We will see it in a little bit. In the intersection of the three of them, you have data science. So to be a data scientist, you need to know a little bit, well, not a little bit. You're supposed to be an expert on something, know your statistics, and know how to code at the same time. What's the intersection between hacking skills and expertise? It's the danger zone. I've lived in the danger zone for so many years. I love it. It's when you after 4 or 5 years working on the same domain, you more or less know quite a bit about it. But if you don't have any way of evaluating what you're doing, at times you don't really know if it's what it should be or if it's not. There's a larger explanation of the Venn diagram here, which actually is misspelled. Let's go. Okay, so more data science resources. Online MOOCs, multi open whatever, online courses. Yeah. There's this. This is a really nice course by Harvard University, CES 109, Data Science. As I said at the beginning, it is a little bit like going straight into the machine learning without knowing your statistics. If you look at the prerequisites, CS 50 is programming 1 and programming 2, more or less, in Europe. But if you're not familiar with this kind of stuff, if you're not familiar with the Europe Poisson distribution and Markov chains and chi-square, multivariate normal, you're going to have issues following the course. So do a statistics MOOC first if you're interested in this kind of stuff. Can you hack your way through it? A lot of people, you will see a lot of talks on the internet, like this one. How to become a data scientist in 6 months, right? The talk is actually quite good. She does say that she spent a year planning how to take those 6 months off, and she also says that she's I believe a project manager in IT, but her undergraduate is in mathematics, so she kind of has a head start if you come from a CS background. So you can kind of hack your way through it, but at one point or the other, you're going to have to go back to at least your statistics. This is a very good talk in PyCon, Statistics for Hackers. It's a good way to ease you into going a little bit deeper into statistics if you're going to go down this path. Be a bit wary of terminology. I mentioned this before, but is it machine learning? Is it data mining? Is it a statistical learning? It depends on where you're looking at it from. If you're a statistician, you're going to say there is a statistical learning. If you are a data scientist, you're probably going to use data mining. The whole machine learning is more of a buzzword or something. And I'm sure someone is thinking, no, they're not the same. Of course they're not the same. They are the same to me. You're going to do very, very similar things with anything. First thing to do is, do you want to figure something out from the data, or do you want to predict something? So, for instance, yesterday the talk on the Stack Overflow, there were a number of insights from the data. That is basically figuring something out from the data. If you want to find people that use F#, go to Iceland, I believe it was, right? But say that you have data for, you have house prices, and you have the number of bedrooms in each of the house. So you can basically plot that, and try to figure out, okay, I have a 4-bedroom house. How much can I get for my house? So that would be a prediction. There's this main 2 types of learning, supervised learning and supervised learning. Supervised learning is basically, I have a data set with tags. So I have an app on my phone, and I walk for 10 minutes, and I click, okay, this was walking. I jog for 10 minutes, and I click on the tag. Now, this was jogging. And I stand for 10 minutes, and I click, and I'm standing, right? So that would be a supervised scenario. And then supervised scenario is just push thousands of images of cats to a neural network and let the network figure out what the characteristics for a cat are. So there are no tags. It's just raw data. There is also, people are starting to talk about reinforcement learning, which is a bit of a mix of the other 2. It's more supervised than unsupervised, but anyway, you will hear it if you start reading about these things. But you're going to do either classification or regression, and you're going to do clustering. By the way, if you have any questions at any time, raise your hand. I'm happy to answer questions while I'm talking. Doesn't have to be at the end. I should have said that earlier. So, cool. So let's go back to the DIY thing, which is part of the title, and to our your things. So I briefly mentioned end-user development at the beginning, and end-user development has that's the definition. We can make it a little bit easier. It's basically, it allows non-professional users to create, modify, or extend software artifacts. And when I mentioned that you've all used it, spreadsheet is an end-user development tool. So with a spreadsheet, you can do something as simple as a to-do list or a list or something, or you can do quite a lot of stuff if you start using formulas, macros, and all that kind of stuff. So the end user is the one that is generating all this content. If you, so some of you might have seen this before. It's a good talk about stuff that you can do with Excel. Anyone use Dreamweaver? No? One person. All right. So it's basically an end-user development tool to create websites. Anyone use LabVIEW? Engineers in the audience? Cool. So that's a SQL query. I've no idea why anyone may think that this is simpler than doing select, count, ID from table. But yeah, that's basically it. And this is eStudio, which ePrime is a tool that is used in psychology quite a bit, neuroscience. You know, when they put you put on one of those helmets with things on your head, and they show you images, and they figure out which part of your brain is active or is not active, that kind of thing. So, a couple of tools for this particular topic. One of them is MIT App Inventor, and the other one is Node-RED. I'm going to try and do a little demo of App Inventor. This might go totally wrong, but I'm going to try, because I need to change the settings of the... Yeah, and now I can't see anything in here. Okay, let me get this. You guys see that? Cool. Let me see. Okay, so this is App Inventor. App Inventor is a drag and drop tool. Have you ever heard of a Scratch? A few hands. Right. App Inventor is a Scratch for mobile phones. So this is your Android app, and if you want to put a button there, and if you want to put a label in there, you just do that. Click on the button and say, I don't know, whoa. Okay, I just have to reload. Yes, I want to log in. Yes, I wrote part of it, so we own everything that you do. And actually, the terms and conditions of App Inventor, you should definitely read them. Sorry, that was an image. And I'll explain why in a moment. So this is basically the layout of your app, right? And this is your blocks area. You to program the behavior of the app, you just drag and drop blocks. So the button has a click event, and in the click event, what you can do is set the label text to let's see, hello world, right? So I'm not connected with my phone, but I could be seeing this stuff on my phone directly. You can check that out at home if you want to. But I can go to build and I can save the APK directly to my computer. That's a native Android app. That's all you need to do for a native Android app. We also have a number of things like sensors, right? So if you use an accelerometer sensor, and you look at the blocks, it has an event that is called acceleration changed. So every time the acceleration changes on the phone, you're going to get the X, Y, and Z axis, right? So as you can see, this is very simple. There's also stuff, and this is why I said about the terms and conditions. If you have a look in here, it has a Twitter component, so you can create a Twitter client. You're going to have to go and read the terms and conditions of the Twitter API. And we also have, let me see, what other stuff. In storage, we have this thing called Fusion Tables, which is a Google API. It's like Excel on steroids or something like that. It's a mix in between a spreadsheet and SQL. So if you use the Fusion Tables component, you are using a Google API. So everything that I said applies. Okay, so this is App Inventor. And let me try and go back to the slides now. Cool. All right. So the accelerometer has a method called shaking, right? So every time you shake your phone, it's gonna fire. It's gonna trigger. So if you put your phone in your pocket and you jump, that's basically activity detection, which is one of the things that I use for activity tracking. Then people need data at different levels of abstraction. Some people need to do X, Y, and Z, but some people just want something like a pedometer. And the pedometer, you can figure out the number of steps and the distance by using these values, but you don't have to because there's already a block that gives you the steps, that kind of thing. So it's very easy to get it started. So once you get the data, how did you send it somewhere? You need some kind of communication tool. You can use HTTP. We have a web component that does get, post, put, and delete. You can do that. Or you can you can save data to a file and send it to a server. In certain occasions, you want to do the classification directly on the phone. If you're into exercise and that kind of stuff, exercise analysis, this is actually exercising as in sports, not as in homework. So that talk is actually really good. You probably want to use MQTT instead of HTTP though. MQTT is a very, very lightweight communication protocol, and it's designed to be machine to machine. So it's not going to drain your battery. It's going to work better. The only thing is that with MQTT, you need a broker in the middle. So your phone is going to send data to a broker, and the broker is basically a publish subscribe system. So from anywhere else, you can subscribe to certain channels. If you want to use a broker, there is Mosquito. There's also, this is all Java, I believe. And if you are into JavaScript or Node, you can use Mosca. And there's public brokers. So when you start doing this stuff, just use iot.eclipse.org and create your own channel. It's obviously not, it's open and it's not secure. If you send data to your channel and someone else sends data to your channel, it's going to arrive there. So at some point, you want your own broker. But to mess up with the stuff and to experiment, just go with this. And this is Node-RED, which is the other tool that I mentioned earlier. Node-RED is basically a transformation tool. It's a flow programming kind of tool. So if you get your MQTT data in here, say that you're getting the X, Y, and Z coordinates from the accelerometer, you can put a little switch in the middle, and the switch, you can put a couple of JavaScript lines in the switch that say the first 1,000 readings, send them to a file, and then email me because I want to know that the data is ready and I want to do something else with it. In the same fashion, you could have a switch that goes to MySQL or MongoDB or a time series database or whatever you want in there. And this is all open source, so if there's a little block that doesn't exist, you just write your own in JavaScript. Cool. So this is the scenario that I just said. So you collect your data with App Inventor, you MQTT it to a broker, and then you subscribe from Node-RED, and you can set it to storage, you can analyze it, you can visualize it. Another example that I'm working on is you send a notification to your phone from Node-RED. So you need this is the Node-RED node that I wrote, and this is basically a component in the app inventory interface that I show you that you just drag and drop it, and it has an event that says receive notification, and you put blocks inside to see to do whatever you want to do. For backend and storage, you can use a commercial solution, but now you know better, and you're going to read the terms and conditions. You can also use this tool called iSense, and you can use your own backend. You can use Parse Server or Solid or roll your own, whatever you like. A little node server would do fine. This is actually iSense. With iSense, you can create these types of projects, and it gets the data in, and it also creates little visualizations for it. And you can create different plots, you can create different graphs, that kind of stuff. If you're gonna roll it yourself, you're probably gonna need a time series database, something like InfluxDB, GitHub, and or if you need real-time data, RethinkDB, and it's also open source. It's also available on GitHub. If you want to graph and monitor, I use Grafana and Prometheus. Not going into these tools, but picture of Parse Server. Okay, so there are many solutions, but remember to read the terms and conditions. And I use Docker for everything. And I'm not talking about using Docker in production. I don't even want to go there. I don't do a lot of production these days, but when I need to get one of the servers up and running, it's just so easy to find a Docker file and you run Docker run whatever, and you have the whole thing running. You don't have to install MySQL and Redis and Mongo and all these dependencies. All the dependencies are in the container. So if you haven't looked at containers yet, it's actually good to spend the time into looking into it. For data analysis, I'm going to show you a few tools. So this is iSense that I showed you earlier. This is a plot of serving size in grams and the calories on the other side. So this is the type of, you can get all types of little plots in there if you want with your data. The ones that are not available will be crossed out. If you're into Python, or not only Python, but Jupyter notebooks with pandas and seaborn. Pandas and seaborn are actually Python, but Jupyter can do other languages, can do R, can do Julia, Python, and I don't know if something else. If you're coming from a computer science background, I would recommend, instead of going directly to the Coursera machine learning course, I would recommend doing Weka, which is this thing in here, data mining with Weka. You see, they're computer scientists. They say data mining. They don't say machine learning. So they have 2 or 3 courses, and they're very good to get started. Let me see what I have in here. If you start doing any kind of machine learning, you're going to come across this data set. It's a data set of flowers, of iris flowers, and they basically measure the sepal length and width and the petal. And they did this for 150 flowers, and they figured out that there are 3 types of species. And this is a visualization with Weka. The red ones are Iris setosa. The green ones are Iris versicolor, and the blue ones are Iris virginica. And Weka does really cool stuff. Like, this is a border separation of things. You can see there's a blue guy in the green zone, another 2 blue guys in here, couple of green guys in there. Those would be misclassified. So if you ask the computer thinks that these guys are blue, and the computer thinks that these guys are green. This is using a naive Bayes algorithm. If you use something different, this is J48, which is a decision tree Bayes algorithm. If you're all computer scientists, or most of you, you know about binary trees and decision trees and all that kind of stuff. You see that the boundaries are actually quite different. There's this blue area here and here. Weka is really nice for this kind of visualizations because you can see what is happening. If you do something with other tools, you run something in the command line, wait for 10 minutes, and then you get some text back. So with Weka, you can actually see the thing running in different iterations. And that's all I have. I've gone a bit over 40 minutes. If you have any questions, or if you want to talk about anything, I'll be around. Thanks very much for listening to me. Any questions now? I don't see any hands. So.
You mentioned that we should read carefully the app inventory.
Yes.
Conditions, and I guess you didn't answer why especially.
Right, so I think I showed there are certain components. So for instance, the Fusion table component uses a Google API. So if you are sending data, or if you're working on an app for a client and you're using a Google API, you're bound by the terms and conditions of the Google API. So certain components in App Inventor have other attachments, yeah, exactly. Yeah. All right, thank you very much, everybody.